Okay, hey guys. We are going to go over imaginary numbers today. Imaginary numbers. Why do we have imaginary numbers? What are they for? And do we really need them? Okay, if they're imaginary. Like you guys left your imaginary friends behind back when you guys were 5 years old. But do we need imaginary numbers? Now, imaginary numbers come about with square roots. And the reason why is uh, once we hit this, let's say, what is the square root of 4? We say that's 2. And what is the idea of a square root? A square root is what number squared would give me this number here. What number squared? Because a square root is a inverse operation of a square. The example is x squared is equal to 4. The inverse operation, let's keep it as a positive. X equals to the square root of 4. What would be that number? And the square root allowed me to go backwards. What squared would give me 4? Okay. What squared would give me 4? Well, the number is 2. So a square root is a tool to allow me to go backwards from a square. It's an inverse operation. And if I think of it that way, fine. What squared is 16? Answer is 4, because 4 times 4 is 16. What squared is 25? Well, that's 5, because 5 times 5 is 25. Now, we have a thing where when we say x squared equals to, that's a 25, we can say x is equal to plus and minus the square root of 25. Why do we say plus and minus? Why do we say plus and minus? Because the square root of 25 sure is 5. So we have two options here, plus 5 and minus 5. Now, why do we have to write both these options? It's because when you initiate the square root for inverse operations, you actually come up with the square gets rid of the positive or negative version. It makes it positive, makes everything positive. Now, if I write 5 squared, plugging in 5, isn't that 25? But if I plug in negative 5 squared, that's also 25. Let me show you that. 5 times 5 is positive 25, but negative 5 times negative 5 is also positive 25. So both these options are completely true. If they're both the same sign, positive times positive, that stays positive. But remember, negative times negative is also a positive answer. So when I ask you x squared equals to 4, you're going to think, oh, the answers are going to be plus 2 and negative 2. We can look at this a different way. If I write x squared minus 4 is equal to 0, if I move the 4 over, I can factor x squared minus 4 as x, 4, and plus and minus. And what makes the first x go to 0? That would be, oops, sorry, I messed up here. I wrote the wrong number. That's a 2. I look excited there. 2 and 2, because 2 times 2 is 4. My first answer would be negative 2. My second answer would be positive 2. Okay, so whether I factor or I solve algebraically, we end up with the answers plus and minus 2. Is that true? Let's double check it. For x squared equals to 4, if x was positive 2 and positive 2, yes, that's 4. And is it also true if it was negative 2? Yeah, that is positive 4. But if I ask you a square root of a negative number, the square root of negative 4, okay, what two exactly the same numbers would give me a negative 4? Is it true? If I wrote x squared equals to negative 4, is this possible? Well, you might say, Mr. Go, 2 works. Well, yeah, 2 does work. When it comes to 2 times 2 is 4. But to get a negative sign, one would have to be positive and one would have to be negative. Again, one would have to be positive, one would have to be negative. But that means that 2 is not the same as negative 2. They're not the same x. They are not the same x. And that means it's not possible. So when we take the square root of negative 4, we say this is a not real answer. It's like you asking your parents, hey, can we go to Disneyland this weekend? And your parents say, this is in your head. you're imagining it, okay, that's not real. So instead, what we do to solve this is we say, you know what? I don't like the negative sign then. You know what? I don't like it. I just don't like it. Okay? Can I get it without jalapenos? Can I get it without chili? It's too spicy for me. So what we do is we do a little trick. And when we're multiplying square roots, then we have to go back and talk about why we have to do this. Is first multiplying radicals. Okay, so here is a rule from Algebra 1. A square root of a times the square root of b is the square root of a times b. What this means is if I'm multiplying square roots, it's almost like two puddles of water. If you push them close enough, don't they go whoop, and don't they mix together? Okay. So if I'm multiplying square root of 5 times the square root of 4, we end up with the square root of 20. That's a general rule. We can also go backwards out of that. A square root of 20 can be written as the square root of 5 times the square root of 4. Hey, I know what the square root of 4 is. That's 2. Square root of 5 times 2 is 2 square root of 5. Another way of writing this is a square root of 20 becomes square root of 20 becomes a square root of 4 and a square root of 5. That's 2 times square root of 5 is 2 square root of 5. Another way, visual way of looking at it. So the rule is if I'm multiplying radicals, you can always multiply them together or take them apart, going backwards. If I give you a problem, 4 square root of 3 times 5 square root of 2. Okay, this is a question that people ask, like, what do I do with these numbers? Numbers outside, multiply numbers outside, and numbers inside, multiply inside the square root. So this becomes 4 times 5. These guys are both outside, and the square root says 3 times 2, which is 6. So it's 20 square root of 6. Just a side note, if you ever were confused or forgot about this rule. Now, why do we need to know this? Is because that's actually the rule that we're going to do. Ish, okay? This is still an impossible task, but this is the ish part. Now, to give you a square root of, let's say, -4, this is already an impossible problem. Okay, this is not a real answer. So what we do is we jump into our imaginary realm, and we're going to actually do this. We're going to say this is really the square root of -1 times the square root of 4. Okay, remember how we said we can combine them or take them apart? So we are going to take them apart right now. So whenever you have a square root of a negative, in reality, these are the mechanics about it. We take out the negative first. And we're going to have a definition. The definition is this. Is the square root of -1 is just the letter I for imaginary. Okay. Because once we hit square root of -4, this is no longer a real number. You're just writing jibbly-jah. All right? You're not even speaking English anymore. So we have to first take out the crap. And we say the square root of -1 is I. And now we can look at the square root of 4. And the square root of 4, it says, so this is definition, and this is imaginary. Definition, imaginary. So our definition here, this is given. This is given. Don't worry about the top to see this. Just worry about what we're working on now. The square root of -1 is I. That is the straight definition. Because this isn't really math. This is me saying, just write that now. Now, what is the square root of 4? I can now take the square root of 4. The square root of 4 is 2. And we'll write 2i because we like writing imaginary numbers after the number, like variables. We write 2x, not x2. If you're not sure why we always write the variables at the back, if I write 2i versus i2, depending how bad your penmanship is, you might think this is I squared, right? That's why I always write the number in front of the variable so you don't think it's an exponent. Okay, this is why. Did you mean I squared or did you mean I2? Okay, so let's go ahead and do a couple more examples here. You probably know these already, but the square root of negative 10, I can't take the square root of negative 10. It's impossible, right? There's no negative times positive that would work. So we say instead you're going to take out the negative 1, leaving the 10 behind, and that's just I squared root of 10, and we are done here because I cannot take a square root of 10. What about it's the square root of negative 144? You guys might be screaming 12, 12, 12, and you're right, but that's also wrong because this is not a real answer. This is impossible. You can't do it. You can't take a square root of negative 10. You wouldn't write it as 10i. Nope. Sorry, 10i. Someone asked me if I would write this as 10i. Nope, because you cannot take a square root of 10. 10i is actually the square root of 100, so it's a totally different number. Okay, good question. So a square root, if I can't take a square root of a square root, you leave it alone. Square root of 10 is square root of 10. Don't force it. Now let's look at this again, 144. I'm going to tell you right now, this is not a real number. So what we do instead is we first take out the negative, and that becomes an I. Well, fine, let's write it the way I've been doing it. But you don't have to write it anymore after we see it this way. And the square root of 144. Now that I took out the negative, that's just I, we can now freely take a square root of 144. What's the square root of 144? It's just going to be 12i. So you can write I times 12, but we rather write 12i. So we don't have any complications. We always take out the negative 1. Yeah, you could just write 12i, Danya. Question?
How would you actually take out the negative 1,
So
actually?
as I mentioned before, think of it like puddles of water, right?
Yeah,
Square roots can bloop together.
I see.
Or you could take them apart however you want.
Oh, I see.
So that
So
move
you're
goes
just
forward
kind
or
of
backwards.
splitting it.
Yes. Okay,
I see.
as long as I leave them as multiplication. So we take this and we say, hey, we're multiplying a square root of negative 1 and a square root of 4. We just bloop, separate them. And we know what the square root of negative 1 by definition is going to be I. That's why it's I square root of 4. Now I can take a square root of 4 freely. We know what that is. That's a real number.
Yeah. All right. Got it. Thank you.
Now, do we have to go through all these steps? Answer is no. If you see a square root of negative 144, you should be comfortable to say that's just 12i. But the mechanics in our head should be saying that, hey, the negative 1 is my imaginary so that I can take a square root of 144. If not, you wouldn't be allowed to. The negative 1 is like your little brother. You can't go anywhere with your little brother. But once you get rid of him, now you can do whatever you want. Right? Now we have a couple of rules for multiplying imaginary numbers. Here's the example. If I say square root of 4 times the square root of negative, let's say negative 5 here, okay? You could write this as one big square root. That would be square root of negative 20. And let's see, will this change versus me just going straight down, okay? So if I go straight down, the square root of 4 is 2. And I can't do any mathematical process to this because it's not real, right? It's like, hey, meet my imaginary friend here. He wants to come out, hang out with us. No, crazy, leave him at home. So we have to first take out the I. And now we can do the process. This is 2i square root of 5. We write the I before the square root because if I wrote it after the square root, you think it's the square root of I. If I wrote it like 2 square root of 5i, depending how long or short your line is, you might think it would be in the square root. That's why we never write anything after the square root. So we write it right here. So let's give us the same answer. First we take out the I, and then 20 is 4 times 5. Square root of 4 is 2, left over 5. Because I take square root of 4 is 2, and I cannot take the square root of 5. I'm rewriting this to make it look nicer, so I don't think it's I squared. I don't want this to look like I squared. It's 2i square root of 5. Now, what if I say the square root of negative 2 times, okay, so here is a problem here, which I made a mistake, which is a common mistake. It's this one here, and this is why I do it. I'm trying to make a big deal. This is a fail. Why? Why is this a fail? Can anyone tell me why this actually was an impossible move? What's wrong with the square root of negative 5? Is it even real? No, it's imaginary. And if something's imaginary, you're not supposed to be able to do real things with it. And multiplication is a real thing. So our problem here is this move was actually a lie already. You cannot do this move. You cannot do this move. You have to first change that square root of negative to an imaginary number. So we have to actually do it this way. Let me say this again. Let me give you another example. If I say square root of 5 times the square root of negative 5, okay? You cannot say square root of negative 25. It might seem like you can, but you can't, because you can't multiply imaginary numbers, right? This is fake. This is fake, okay? This is fake. This is fake with a real. That doesn't make any sense right now. What we do is instead, we have to change it to square root of 5 times imaginary square root of 5. Now we can say this is I square root of 25, which is just 5i. I'm saying this is because I'm going to show you a situation where you will have a conflict of interest. And it's this. If I say the square root of negative, okay, I'm going to use different numbering so you guys don't get super confused. Negative 10 times the square root of negative 10. So here is the false problem. This is where we mess up. This is not, oh, Mr. Code, negative 10 times negative 10 becomes a positive 100, which is 10. This is a fail. If you do this, we've messed up already. It's like you made it saying 2 plus 2 is 2. Just making up crap. Why? Because these aren't real numbers. We can't do real processes to these. What you have to do is actually change this to an imaginary number first. And this becomes I squared square root of 100, which is then become 10i squared. Why is this true? Why is this true? The issue is that we learn all these skills about multiplying, adding, subtracting. These are all with the regular numbers. But what if I told you this was an instant fail already? You can't take a square root of negative 10. If you can't take a square root of negative 10, how can you multiply numbers by something that can't exist? So mathematicians said, you know what, we're going to come up with a new field of numbers, a new range of numbers. And they came up with these called imaginary numbers. And by definition, if I take out the negative first, then we can have a list of rules that we can mimic the real number set. So, okay, the way I got the exponent was what's I times I? What's x times x? That's x squared. So I times I is mimicking the real number set. So I times I is I squared. I times I is I squared. Okay. Now, I'm going to go ahead and give you something else just real quick here. It's that the rules for imaginary numbers is first, our first definition is that the square root of negative 1 is I. That's our first rule. Oh my gosh, I'm going over time. The second rule is this. I squared is negative 1. Whenever you see I squared, that becomes negative 1. Why? Why would I squared become negative 1? I squared is really I times I, okay? Which is really square root of negative 1 times square root of negative 1. But can I do square root of negative 1 times negative 1? You can't. Remember, they're supposed to be impossible. So, but what if I write this instead? What is a square root of negative 1 squared? What is ideally you're expecting to happen? This is not true, okay? This is not really happening. This is what we're going to call by definition. Have your parents ever said, when you're sharing stuff with your little brothers or sisters, just give it to them? Why? Because I said so. It's not his turn. I don't care. I said so. You guys ever feel that? Feel my pain? And this is what's happening. I squared is the square root of negative 1 squared. And this doesn't exist in math. But what should it be? What does a square and square root do to each other? They should cancel out and you should end up with a square root, with a negative 1. This is what mathematicians have decided on and agreed upon, is that I squared will always become negative 1. We get it. This math should not work. This math should not work. But we have all agreed to say, let it work. Give him the toy. Just give it to him. So whenever we have I squared, the answer is negative 1. Negative 1, yes, negative 1. So our answer back here, this is negative 10. Coming back here, I squared is a negative 1 instead. That gives us negative 10. Now, I want to go back here and look at this negative 10 problem real quick. Sorry, just right here, negative 10. If I wrote square root of negative 10 times square root of negative 10, these numbers don't exist, okay? Remember, we're dead in the water already. But couldn't I write two same numbers multiplying together as a squared problem? And what should a square and a square root do to each other? They should cancel out. So this should be negative 10, what we expected. Now, if you followed our math rules before and you said, hey, can't I multiply them together? Doesn't negative become a positive? This should be a positive 10, Mr. Ko. And that's why it's an insta-fail. This was an impossible move with impossible numbers. You cannot do this skill. It doesn't work. You can't combine things that don't exist. Can I repeat where I got the exponent and how can you explain the difference between the one with 5 and the one with 10? Okay, the one with 5 here, I can't multiply. This is not true. You can't just multiply a real number and something that doesn't exist. This does not exist. This is fake. This is a lie. So what mathematicians said, to deal with your lie, we're going to take out the lie. Write the negative on the outside first, and then we can do the work. Square root of 5 times square root of 5 is 25, leaving I on the outside. Okay? It's almost like walking around with your dog and you want to go to a restaurant and say, no, leave your pet outside. Fine. Leave your pet outside. You can deal with him. The pet is still outside. With 10, they're both negative. See how they're both negative? And when I tried multiplying them together, oh, that should be a positive here. No. You've already failed. You already did something you shouldn't have. You brought your pet inside. Okay? You brought your freaking dog in your backpack to school. No, you shouldn't have done that. So what we do is we first take out the negative first. I times I is I squared, and 10 times 10 is 100. Now we can do the math. Square root of 10, 100 is 10. I squared is really negative 1. I squared is really negative 1. So let me go ahead and kind of bring this. Okay, one more step. Let's keep on going. What if I wrote I cubed? Okay, what's I cubed? What's I cubed? Well, to simplify this, isn't I cubed really I times I times I? But instead, we're going to write it this way. Isn't this really I squared times I? That's another way of looking at it. I squared times I. What do we say by definition I squared is? I squared is just a negative 1 I, which is just negative I. I cubed will always be negative I. I cubed will always be negative I. Let's say y again. I cubed is really I squared times I. I squared is negative 1. So we're back to negative I. What's I to the fourth? I to the fourth is I squared times I squared. What's I squared times I squared? Well, isn't I squared negative 1 by definition? By definition, I squared is by definition negative 1. What's negative times negative? A positive 1. I to the fourth will always be positive 1. What's I to the fifth? I to the fifth is I to the fourth times I. I to the fourth is 1. I to the fifth is going to be just I. You might want to rewatch this section, okay? What's I to the sixth? That's I to the fourth. So what we do is we try to pick our easiest I, whether it's I squared or I to the fourth. Well, I to the sixth is I to the fourth times I squared. That's just 1 times I. Oh, sorry, 1 times negative 1. I'm sorry. I squared is negative 1, right? And that's negative 1. And if I keep going, we can do an I to 100. What's I to 100? It turns out that that's actually just 1. Now, why is it just 1? It's because every time we hit 4 i's, we go back to 1. So if I say, let me show you the iClock. Here's my iClock. iPhone, okay? iClock. Here's my iClock. We have I squared, I cubed, and I to the fourth. Okay, here's our clock. I squared, so I is just I squared is negative 1, I cubed is negative I, and I to the fourth is 1. So here we go. If I say I to the fourth, okay, going around the clock, isn't I to the fourth just back to 1? That's 1. What's I to the fifth? Well, that's 1, 2, 3, 4, 5. We're back to I. What's I to the 10th? Okay, go in my iClock. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're at I squared, which is negative 1. I is the square root. Again, repeat, I is the square root of negative 1, which it means it's not possible, it's impossible. So that's why we had to come up with a definition to say, hey, everyone, we can't do this. Just stop. Everyone stop. Just write I instead. If I take the square root of negative 36, Mr. Ko, that's a 6, right? No. Stop. Just stop. We have to first take out the negative, and now we can take a square root of 36. You can't do any work with a negative square root. You have to first take it out, and then we can then continue our work. It's like seeing hair in your food. You got to take it out first. So here is our thing about i's. Every time we have 4 i's, you restart the count. If I say I to the 10 again, right? Isn't this really just I to the fourth? I to the fourth, and then I squared? Well, that's just 1, 1, and negative 1. That's why your answer is negative 1. Your answers continue to repeat over and over along this I clock, going in circles and circles. Okay, like number 10. Let's go back. Do me like the square root of negative. Let's say negative. Okay, let's do. Someone asked me to go back to do a different problem. Let's say negative 5 times the square root of negative 10 here. Okay, let's use this example. Can I multiply these fake numbers together? These impossible numbers together? No. And before imaginary numbers were discovered, they just said, oh, done, just walk away. Don't even bother trying this anymore. You're dead. Why'd you write like gibberish to me? And they said, you know what? We need to continue the math because physics isn't going to stop. So instead, they wrote an imaginary range of numbers. So they just took out the imaginary number I, the negative 1, to become imaginary. Now we can say, hey, well, fine. That's just I squared times the square root of 10. Oh, sorry, 10 times 5 is 50. See, we are able to do the math. We can continue using all our real world number properties. This becomes a negative 1. Square root of 50 is 5, 10, 5, 2. I have a pair of 5s. So times 5 square root of 2. This is negative 5 square root of 2. Now, this is legit the answer. If you ignore the rules of what's fake news here, you would have said, oh, Mr. Ko, the square root of negative 5 times the square root of negative 10 is negative, which becomes a positive 50. Oh, that's just 5 square root of 2. And these are not the same answers. This is wrong. This is you not listening. This is bad. This is on fire. This is wrong. So we have to take out the imaginary number first before we can continue the work. Okay, last step is adding. I'm sorry, I'm running out of time. Gosh, I should. Okay, this will take me only 1 minute. Okay, if I say the square root of a negative 20 plus the square root of negative 5. Okay. Right now, I can't do anything to this because they're both negative. So what you have to do, you have to rewrite it. I square root of 20 plus I square root of 5. Still, okay, I can work with this. Square root of 20 now is 20 is 2 times 10, 2 times 5. Everyone cool with that? Breaking down the square root. I know, I got it. This is the last one. Is 2I square root of 5 plus I square root of 5. So take a look here. I made the square root of 20 into 2 square root of 5. And I made, that, okay. Now look, these are actually like terms now. This is, what's 2I plus I? What is 2 ice creams plus 1 ice cream? You have 3 ice creams. So we take our like terms based on I and the square root now. Okay, so if you have to add square roots that are negative, you have to first simplify them to see if they are like terms after the fact. Okay, if they're not, then you can't add them.